Welcome back to Coding CEO, the channel where I empower you to become the CEO of your own coding journey. In today's video, we are going to dive deep into the concepts of Java fundamentals. If you somewhat missed my first video, do check it out. But for you people, I introduced the Java again in few lines. Basically, Java is a popular programming language that was developed by Sun Microsystems, now which is owned by Oracle Corporation, in mid 1990s. In 1995, Java has revealed to the world of programming, so we have a new language called Java in 1995. Java was designed to be a platform independent, meaning that Java program can run on any operating system that has a Java virtual machine, that is JVM installed. We call this concept as Vora, write once, run anywhere. We will cover all these concepts in today's video. In this Java fundamental tutorial, we will see how memory units are there in computers, how Java has Vora concept in it, how JVM works in real programming, what is main method, what are the variables and data types. Covering these many basics, we will further cover the typecasting, the truncations, identifier, naming conventions, some operators, some conditional statement, that is if else or switch cases. We will also see the loops, the while loop, for loop, do while loop. There is one more loop, we will see it in the further lectures. We have to use the scanner class to interact with the user to get the user input. Then the fascinating star patterns, we will draw it using the programming so that you will fall in love into the programming. After covering these many fundamentals, we will just want to dive deep into the Java programming. Now let's break down how a Java program works step by step while discussing the memory units involved. First of all, the Java code we have write in any IDEs or anywhere, we have to store it as a .java file. So the .java file is a source code of our program. Java has Vora concept, begins with the source code. Developers write Java code in human readable .java files, following Java syntax and programming paradigm. After that, Java compiles its code, and the Java source code, after compiled into a byte code using a Java compiler, that is nothing but a Java C. This is the Java as a language and C as an acronym for compiler. If you have a file name called demo.java, you need to write java c demo.java. After running this command on your command prompt, you will successfully compile the demo.java. This byte code is a platform independent representation of the source code and adheres to the Java virtual machine specifications. What is that Vora impact we are talking about? At this stage, the Vora concepts come into the play. So the compiled byte code is not tied to any specific hardware or operating system. It is designed to be executed on any systems with a compatible JVM. So let's take an example of OS. Okay, so I have an OS of Windows. So I have a Windows OS and I have write a .java code. Okay, this is the source code I write in my Windows operating system. One of my friend who's using Linux OS wants to access this Java code and run that Java code in his machine. So what I can do, I can compile this code and convert it into .class file, right? .class file. What is this .class file? After we will compile our .java file, we have get a byte code. The source code gets converted into byte code, and that byte code has a extension called dot class. Okay, so that byte code I can share to any OS. Okay, maybe it is Linux, maybe it is a Windows only, maybe it is a Mac only. Okay, so if my friend uses Linux and he wants to run this Java file, he can download that dot class file from internet, and with the help of the JVM specifications or JVM specified to his own Linux OS, he can work on my Java file using that dot class file and a JVM. So this is nothing but a Vora concept. But what is the one condition? He has to be installed a JVM which is specific to his Linux OS. So what is Vora impact? We have covered that. What is bytecode? That is dot class file. After compilation, the bytecode is stored in dot class files. These files contain the standardized bytecode instructions that can be understood by any JVM. What is JVM? Okay, what is JVM? It is nothing but a Java virtual machine. That's the full form. But when a Java program is executed, the JVM interprets and executes the bytecode, managing memory and executing instructions as required. JVM plays a crucial role in enabling the Vora concept. It abstracts away the underlying hardware and operating system differences, allowing the same bytecode to be executed consistently across different platforms. The JVM executes the bytecode sequentially, following the program's logic, invoking methods, and managing memory. We have then CPU execution. What is CPU? Central Processing Unit. This is the brain of the computer. We usually say it is a brain of our computer system because it helps to process any types of programs. So the CPU executes the bytecode instructions fetched from the memory by the JVM. Here a RAM concept has come. A hard disk concept has come. What is hard disk? Hard disk is nothing but the permanent storage. What is RAM? It is a random access memory. All the files we have to store on hard disk only, and at the time of execution, CPU fetch that file from hard disk and get it into the RAM, and then CPU can able to execute or work on that Java file. So the CPU's role is more about executing the instructions in a platform specific manner, but the JVM ensures that the platform differences are abstracted away, allowing the same bytecode to produce consistent result on various platforms. In summary, the Vora concept is integral to how a Java program works. It emphasizes writing code once, compiling it into platform-independent bytecode, and relying on the JVM to ensure that the same code can be executed seamlessly on different devices and operating systems. Thanks to its ability to handle the platform-specific aspects and maintain consistency across the diverse environment. There are lots of level languages. That is what I mean to say is we have a machine level language, which is also known as a 0-1 language or a binary language, right? So our machine or our computer or our system can only understand machine level or binary level language, that is 0 and 1s. If you want to give the command that is, hey machine, I want to print hello world in my Java program, but machine understand what? Machine understand only 0-1 language. After that we have a assembly level language, which is nothing but our simple English language coding. Again we have a low level language as well as the high level language. In high level language we have mostly used plus, minus, multiply, mod, divide, and if, else. print, scan, any type of words we have used that is in the high level language. So the Python language, the Java language, the C++ language, all are high level language. So how our machine will understand these types of language? With the help of compiler. What is the role of the compiler here? Compiler basically converts HLL to MLL. What is HLL? It is high level language to machine level language. We also have a concept known as assembler. What is the difference between compiler and assembler? Compiler basically converts high level language to machine level language, but assembler do assembly level language to machine level language. So the next concept we have is compiled versus interpreted. So my question to you is Java a compiled time language or an interpreted language? Before answering this question, I want you to understand what is compiled language, what is interpreted language. A compiled language is one in which the source code is translated into machine readable code, often referred to as machine code or a binary code, before its execution. This compilation process is carried out by a compiler, which converts the entire source code into an executable file or a format that can be directly executed by computer's hardware. When you write a program in a compiled language such as C or C++, you create a source code files. You then use a compiler to translate these files into executable programs. The resulting executable is often faster in terms of execution speed because the code has been optimized and translated into a format that a computer's hardware can directly understand. However, this executable is typically platform specific, meaning it may not run on different operating systems or architectures without modifications or recompilation. Moving towards the next part, the interpreted language part. And interpreted language, on the other hand, is one in which the source code is executed directly by the interpreter, line by line. Instead of compiling the entire code base into a machine code, the interpreter reads and executes the code statement in a sequential manner. This approach allows for more flexibility and platform independence, as the same source code can be executed on different platforms as long as an appropriate interpreter is available. Languages like Python, Ruby, and JavaScript are often interpreted. In an interpreted language, you provide a source code to the interpreter and it processes the code at runtime only, executing the instructions without producing a separate compiled executable. What Java has its approach towards a compiled or a interpreted. So Java suits somewhat in between these two models. Java source code is compiled into an intermediate form called bytecode using the Java compiler, that is JavaC. This bytecode is a machine code but is instead a platform independent representation of the source code. Then the Java Virtual Machine JVM, an interpreter for a bytecode, reads and executes the bytecode on the target machine. The combination of the compilation to bytecode and interpretation by the JVM of the bytecode provides a compromise between the benefits of compiled language, such as performance optimization, and the benefits of interpreted language as well, such as platform independence. This is often referred to as a compile once, run in there concept, where Java code is compiled into bytecode that can be executed on any system with a compatible JVM. This makes Java both a compiled and interpreted language, but interpretation is carried out by the JVM rather than directly by the computer's hardware. So that's all from this video. This is CodingCEO signing off. Keep coding, keep conquering, and keep being the CEO of your own coding dreams. Thanks a lot.